Hello my dear students. In this video I am going to talk about Gauss-Seidel method. Gauss-Seidel method is an iterative scheme which we use to find the approximate solution of system of linear equations. For our convenience purpose, let's consider the system of two linear equations in two variables only. They are written as, the first equation is written as a11x1 plus a12x2 is equals to b1. And the second equation is written as a21x1 plus a22x2 is equals to b2, where these numbers a11, a12, a21, a22 are known as coefficients and they can be any real or complex number, whereas x1 and x2 are known as unknown variables. b1 and b2 are considered as constants, which are written on the right hand side of these equations. The algorithm of Gauss-Seidel method says that we need to find the solution expression of the first variable from the first equation and the solution expression of the second variable from the second equation. So we need to find the solution expression of x1 from the first equation. So we need to move this second term on the right hand side of the equation and remove this coefficient a11, which is multiplied with x1. Hence the solution expression of x1 is written as 1 upon a11 whole multiplied with the expression b1 minus a12 x2. Similarly, the solution expression of x2 is equals to 1 upon a22 whole multiplied with b2 minus a21 x1. Once we have obtained the solution expressions for the variables, we can construct the Gauss-Seidel iterative scheme by just taking the superscript k plus 1 on the left hand side variables and superscript k on the right hand side variables, where the value of k is equals to 0, 1, 2, 3 and so on. The symbol x1 superscript k plus 1, x2 superscript k plus 1 represents the k plus 1th solution, approximate solution, whereas x1 raised k, x2 raised k, this represents the kth approximate solution of the given system. The first iteration can be performed by taking the value of k is equals to 0 in this iterative scheme. The solution obtained by taking k is equals to 0 is the first approximate solution, which is now represented as x1 superscript 1, x2 superscript 1, and we can see that on the right hand side this is x1 superscript 0, x2 superscript 0. These two representations are known as the initial solution. Now whenever we want to find the first approximate solution, at the first stage we don't know what is the value of the initial solution, so we need to take the guess of this initial solution. The question is that what should be that guess? Is there any restriction over it? The answer of this question is there is no restriction. You can take any value of the initial solution. Once you have found the first approximate solution, you carry out the second iteration by taking the value of k is equals to 1. Then the second approximate solution can be found by substituting the value of the first approximate solution in the iterative scheme, which we have already found in the previous iteration. Similarly, the second approximate solution can be utilized in the third iteration by taking k is equals to 2 into this iterative scheme to find the third approximate solution. We can carry out this iterative procedure until we get the required approximate solution. As you can see from this table that as we take the successive values of k, we are getting sequence of approximate solution starting from the initial solution. One more thing which I want to mention here, that this sequence of approximate solutions will converge to the exact solution of the given system if the given system of linear equation is a strictly diagonally dominant system. It means that the absolute value of the leading diagonal element of the first row should be greater than the sum of the absolute values of the other coefficients in that row. Hence, for this system, the absolute value of a11 should be greater than the absolute value of a12 and for the second row the absolute value of A22 should be greater than the absolute value of A21. We have already discussed about the strictly diagonally dominant matrix and the strictly diagonally dominant systems in a separate video. You can click the I button on the screen to watch that video, and the link is also in the description box. The other question which arises here is that for how long we have to carry out this iterative procedure. There are two options. If you already know the exact solution, then you need to find the error between the exact and the approximate solution. If the difference is very small, then you can take that approximate solution as your required approximate solution. And the second option is, if you don't know the exact solution, then you need to take the error between two consecutive approximate solutions. If the difference is very small, then you can take that approximate solution as your required approximate solution. Let's understand this algorithm by taking the system of two linear equations. 7x1 minus x2 is equals to 6, x1 minus 5x2 is equals to minus 4. As you can see that the exact solution of this system of linear equation is x1 is equals to 1 and x2 is equals to 1. Moreover, we can also see that this system is a strictly diagonally dominant system because the absolute value of 7 is greater than the absolute value of minus 1 and the absolute value of minus 5 is greater than the absolute value of 1. Hence, the approximate solutions, the sequence of approximate solution which we are going to obtain using Gauss-Seidel method will surely converge to the exact solution given here. Now the first step of Gauss-Seidel method is to find the solution expression of the variables. So x1 would be equals to 1 upon 7 whole multiplied with the expression 6 plus x2. x2 is equals to 1 upon 5 whole multiplied with the expression 4 plus x1. Once we have obtained the solution expressions of these variables, we can construct the Gauss-Seidel iterative scheme by just raising the superscript k plus 1 on the left hand side variables and superscript k on the right hand side variables, where we can take the value of k equals to 0, 1, 2 and so on. The first iterative scheme can be carried out by taking the value of k equals to 0 into this iterative scheme. As you can see that now we are going to find the first approximate solution and we need the initial solution to find this approximate solution. So let's take the initial solution as x1 is equals to 0 and x2 is equals to 0. Substituting these values into this iterative scheme, we get the first approximate solution of x1 is equals to 0.85714 and the first approximate solution of x2 is equals to 0.8. Now we can take the second iteration by taking the value of k equals to 1 to find the second approximate solution, where we need the first approximate solution which we have already found in the previous iteration. So we'll just take the first approximate solution from the first iteration, substitute it here into this iterative scheme to find the second approximate solution, which is 0.97959, and the second approximate solution of x2 is 0.96. Similarly, we can utilize this second approximate solution to find the third approximate solution, and the procedure goes on and on. Here in this table you can see that I have computed the approximate solutions up to the sixth approximate solution by taking the value of k up to k equals to 5. As you can see that we have started from the initial solution 0, 0, and as we are taking the successive values of k, the initial solution, the approximate solution, is getting closer and closer to the exact solution, which is 1 and 1. We can also see this by finding the error between the exact solution 1 and 1 with the approximate solution 0.99999, 0.99994. We can see that the error is 10 power minus 5, which I consider is very small. So I take this approximate solution, the sixth approximate solution, as the required approximate solution obtained using Gauss-Seidel method. If you have any question regarding this discussion, this video, you can write it into the comment section. I will try my best to address those queries. If you like this video, hit the like button, share it with your other class fellows, and don't forget to subscribe my channel.